Okay, this is our last chapter, or last section, excuse me, chapter 1. We're starting to look at functions. We're going to spend a lot of time looking at functions in chapter 5 and chapter 6. Where we're going to really introduce it right now, really some graphing and ways that we can generate functions from and some ordered pairs. So we're going to start by looking at this graph here. We've got what's called a coordinate plane or a Cartesian plane. And the coordinate plane is formed by the intersection of that red line and the blue line. And so I'm going to try and point to some arrows here. So we got the red line there, and we got the blue line. And when we intersect those two number lines, we get what we call the coordinate plane. And the two number lines that we're talking about are, like I said, that red line and the blue line there. And in this form, rather than calling it a number line, call them axes. So go ahead and write that down. You'll get that word in history as well, but in something different. So the axes are our number lines, the red line and the blue line there. Where they intersect, where they come together, we call the origin. And that origin, if you look over on the right, is right there in green. It's origin. Once you're going to fill that in, you don't have to use green, but you're going to fill it in. So the origin is at 0, 0. It's the 0 point on the red number line, the red axis, and it's the 0 point on the y number line, the y-axis. And so we're going to be actually the blue number line, the blue axis. I just gave it away a little bit, but the vertical, the one that goes up and down, the blue line, the vertical is called the y-axis. So you can fill that in the words, and you can fill that in on the picture. The y-axis is the blue vertical number line. And it starts at 0 in the middle at origin and counts up from there. And so we get 1, 2, 3, 4, etc. -1, -2, -3, -4. And that's on the y-axis. If you haven't already guessed it, the red axis is called the x-axis. And so we're going to put that in there as well, x-axis, which again is our standard number line. Goes horizontally from left to right with 0 in the middle. 1, 2, 3, 4, etc. -1, -2, -3, etc. from that direction. And so the coordinate plane or the Cartesian plane is the intersection of those two axes, and that gives us two-dimensional space. So we can draw things in two dimensions with two number lines. So we get that coordinate plane. So points, we're going to be looking at points. Points have no width, no depth, no nothing. They're very weird. They have just a point. And on the coordinate plane, we describe that with an ordered pair. Okay? And so an ordered pair, and I'm going to fill that in, an ordered pair has two parts, pair, so it's a pair. And we have to keep them in order. Just like in the alphabet, we have an x coordinate, and then we have a y coordinate. And it goes in that order. That is important. It goes x and then y. So the x coordinate tells us where on the x-axis the point is. And the y coordinate tells us where on the y-axis that point is. And we often name points with capital letters, which you'll see in a minute. And then it's the x-axis and the y-axis, the x-coordinate and the y-coordinate. And it's easy to remember which one comes first because it's alphabetical, x and then y, just like in the alphabet. And you can read that hint there if you want. So, graphing the points. I'm going to graph T, and I'll let you try U and A. So graphing point T, I'm going to graph it in red here, -4, 4. So there's my ordered pair for T. That's my x coordinate, and that's my y coordinate. For this one here, for T at least, I want you to put the x and the y. So x is our x coordinate is -4, our y coordinate is 4. So on the number line, I'm going to start at the origin. I'm going to start at 0, 0 here with this point. And I'm going to go -4 on the x-axis, and then I'm going to go +4 on the y-axis. And my point that I'm going to create then is right here. And I'm going to label that point T. And so we always start at the origin. We always start right in the middle. Everything starts at the origin. That's where life originated from. We get that word originate from origin. So everything originates from the origin. It starts at the origin. And then we do our x first, and then a y, just like in the alphabet. So we go -4 on the x-axis in red, +4 on the y-axis in blue, and we've got our point T. Try the other ones. and then we'll do it together. Okay, I'm going to assume that you tried the other ones. I'm going to erase my marks here, and we'll try this again. So for u, we got our x coordinate is O, our y coordinate is -5. So I start at the origin, and for my x, I go left and right 0. I do not go left or right at all. And then for my blue, for my y-axis, I go -5. So I'm going to go down 5, and I'm going to make my point, and I'm going to label that point U. It is important that you label it, because otherwise you just have a whole bunch of points. I don't know which one is which. So you need to label your points with a capital letter that denotes which point you're labeling, or which point you're plotting. All right, so again, for the point A, I'm going to have my x coordinate, my y coordinate, my x coordinate -2, my y coordinate -3. And so if I start at the origin, I originate at the origin. I go x left and right first. I go -2 on the x-axis, and then I go -3 on the y-axis, and now I have my point. And I call that point A. You do not need to draw those lines in there. I did, because you can't see when I point at them. And so I drew those lines in. What I need to see is what's on the board right now, or what's on the screen right now, I guess, for you. Because I need to see those 3 points, and I need to see them labeled with U, A, and T. The other direction that we have to be able to go with this is finding the points and telling people where they are. And this is essentially where the coordinate plane came from, is directions. If you want to give somebody directions to your house, to your business, you need to be able to tell them where to go. So you say, okay, well, where are you? Well, if I'm at the intersection of 4 and 1. So if I'm point G, I'm at the intersection of 4 and 1, at the intersection of 4th Street and 1st Avenue. I'm at the intersection of 4 and 1. And so my x coordinate for G is going to be 4. My y coordinate for G is going to be 1. And so if I go, I've got my x, I've got my y, I'm going to have the coordinate pair, or the ordered pair for G is going to be 4, 1. Because I go over 4 on the x, and I go up 1 on the y. And so that coordinate pair, that ordered pair, is going to be 4, 1. Try the other ones. Get an ordered pair, x then y, just like in the alphabet, for the other 3 points. I'm going to assume we did that. So for E, if I look at E is well, it's right there. And if I go -3 on the x, and I go +2 on the y, I get an ordered pair of -3, 2. And then I've got my ordered pair. For F, I'm going to do the same thing. I'm going to go left and right 0 on the x, which I always start at the origin. I'm going to go up 3. So go 0 and then 3. For H, I go left and right -1, and then I go up and down -1 as well. And so my ordered pair, -1 in the x, -1 in the y. I've got my ordered pair. So I'm giving directions. I'm telling somebody where to go. Where are you located? I'm located at the intersection of -1 and -1. I'm at the intersection of -3 and 2. We always do the x first, just like in the alphabet. We do the x-axis, then the y-axis. And that is important, that we order our ordered pairs correctly. So where we start to find these, where we start to use these, is in a function. So in a function, the value of y is the output. Y is what's coming out of the function. You maybe have heard of a function machine. We're not going to be doing much with function machines, but it's the same general concept, that y is what comes out of the function machine. So if you had a function machine, and we've had this before, y comes out of the function machine, and x is the x coordinate. X goes into the function machine. You do stuff inside, like 10x plus 5. And so if you put 1 into the function machine, if x is 1, you do 10 times 1 plus 5, and you get y was 15. If you plugged in x was 5, 10 times 5 is 50, plus 5 is 55, so y comes out as 55. And that input-output is something that we're going to talk a lot about. We're going to range and domain, which are very computer-based language that you're going to see a lot if you get into any stems from math, input and output. And so these functions are what we're going to start touching on in chapter 1 very briefly, and then we'll get a lot more in depth in chapter 4, 5, and 6. So the way we're going to deal with functions for chapter 1 is we're going to look at some real world situations. An engraver, so we can engrave things, charges a setup fee of $10 plus $2 for every word engraved. So I'm going to stop there. I'm writing an equation for this. Right? I want to know if there's 5 things that they're engraving, 10 things that they're engraving, 15, 20, 50, 62, 73, whatever they're engraving, I want to know how much it's going to cost. So I'm going to look at this again. This is an engraver charges a setup fee. So no matter what you're engraving, you have to pay the same amount every for that first try. It would be like if you're in a gym, you have a sign-up fee, or for your phone, there's a sign-up fee. So no matter how many minutes you use, you still have to pay a certain amount. So the setup fee is $10. And that doesn't matter how many you engrave. Plus, here's that word plus right there, plus $2 for everything engraved. I'm going to go ahead and use X for that. So for every item that you engrave, we got a $2 setup fee. And there's my equation. So the cost, Y, is going to equal $10 for the setup plus $2 for every word engraved. Now, this particular problem says, well, what if there are 5 items being engraved? Well, I'm going to use my equation, Y equals 10 plus 2X, and I'm going to substitute that in. I'm going to see what happens. So if X is 5, there are 5 things that I'm engraving. I've got 10 plus 2 times 5 things that I'm engraving. And I want to know what that equals. Well, I know it's a 10 plus 2 times, well, I do multiplication first. 2 times 5 is 10, plus 10 is 20. So my Y value, my output, how much does it cost, is 20. Now that I have an X, and then now I have a Y, I've got an ordered pair, XY. So my ordered pair, XY, 5, 20. That's an ordered pair, 5, 20. We'll do another one here. Once you have the equation set up, it's as simple as plugging it in. It's called plug and chart. You just plug it in and you do it. So I've got 10 items engraved to engrave, 15 items to engrave, 20 items to engrave. Let's see what happens. So Y equals $10 for that setup plus 2 times 10 items that I'm engraving. What am I going to get? 2 times 10 is 20, plus 10 more is 30. If you get the idea, go ahead and fill in the rest of the table here. So that X coordinate, Y coordinate would going to be 10, 30. Try to do 2. Try to pause it, try to do 2. All right, I'm assuming you filled it in. And so I'm going to fill it in as well. I'm going to go a little bit quicker here. So I'm going to have different numbers. I'm going to have 15 for that one. And then if I multiply, I should get 40. And you might even see a pattern in the Y's here. You notice that our X's are going up by 5s, and our Y's are going up by 10s. And so you can almost anticipate what's going to happen with this particular function. It doesn't always work for every function that it's nice and clean like that. However, there will always be some kind of pattern. I didn't color code that quite right, but you'll have to forgive me. And so if we fill in our pattern, we've got our 4 X, Y coordinates, we've got our 4 ordered pairs. We're then going to graph those ordered pairs. Now, this particular graph is not quite set up perfectly, and so we're going to have to manipulate it a little bit. And so I'm going to change this in my X coordinate. Rather than going by 1s, I'm going to change this, going to go by 5. So I'm going to go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And I'm only doing that so I can fit everything on. This particular graph is not quite set up nicely. For the y-axis, I'm going to go by 10. So I'm going to go 10, 20, 30, 40, 50, and so on up the line. Okay, I can do that for the negatives as well, but I don't have any negatives to worry about for this problem. I'm going to graph those points. Just like we did in our other notes, I'm going to graph those ordered pairs. So the first one, 520. I always start at the origin, I go 5 on the x-axis and 20 on the y-axis. The next one, 10, 30. So I go 10 on the x-axis, 30 on the y-axis. The next one, 15 to 40. 15 on the x-axis, and I think you get the idea, so go ahead and work fast with me if you need to. And 20, 50. And it should create, at least for this particular graph, a nice straight line. And there we go. We've got our points. Try this one on your own. Pause it, try it on your own, and I will fill it in here a little bit faster. I assume you tried it on your own. So we're given an equation for this, so we're going to come up with it. We are given x values to use, -2, -1, 0, and 1. And I'm just going to substitute into this equation my different values for x. And so we're going to substitute in, so I've essentially got 4 different problems that I'm using for this problem. And if I find all my y values from there, I've got -4 plus 1, -3, -2 plus 1, -1, 0 plus 1, 1, and 2 plus 1, 3. And so again, it is a pattern. It goes up by 2 every time. And my x, y ordered pair, -2, -3, -1, -1, 0, 1, and 1, 3. Then I can graph those points. So I have to change my graph for this one. Luckily, points work perfectly. And so at -2, -3, I start at the origin. I go with -2 on the x, and -3 on the y, and make my first point. -1, -1. Start at the origin, -1 on the x, -1 on the y. Start at the origin, 0 on the x, +1 on the y. Start at the origin, 1 on the x, 3 on the y. And again, it makes a nice straight line for this particular graph. And so we have our points. Okay, that's the end. We're going to work on some different problems and practice this a little more.